Hi there, my name is Trisha Moyer, and this is my final project for CS570 for Spring 2017. So I'm just going to get started here. My data that I have is the 2016 racial profiling data sets for arrests. This is off of the City of Austin website for the Austin Police Department arrests. So we're just going to go ahead and add it to our data frame, and then we're just going to make sure that it actually got added to the data frame. These are the variables real fast. As you can see, there's a lot of categorical variables, so this might affect our outcome, but we shall see. So first, the rep date is just the date of the arrest, which is not that important. Time, we can see that most of the arrests were from 10 p.m. and 2 a.m., which I think is not really unexpected. I think a lot of arrests are probably done in the nighttime, so I mean that's not really that surprising. Next is sex, and we see that there's a lot more males than females. Next is age at offense, which we can see most of them are between the ages of 20s to their 30s. We have a few outliers here, 13-year-old, 14-year-old, stuff like that. And then we also have this weird 0.0 that we'll have to deal with in a little bit. Next is the race description. We can see that Hispanic or Latino is a lot higher. The Hispanic and Latino and white are actually about the same, but they are significantly higher than the rest of the races, which you can see here in this histogram. Next is location. We can see a lot of them here are off of 6th Street, which is not surprising because 6th Street is the main drag of Austin where all of the bars are, so it's not really surprising that there's a lot of arrests there. Next we have person searched. It's either yes or no, they were searched, the reason for their stops. Here we see violation of transportation code is the #1 reason, which isn't really that surprising. I mean, most people are arrested because of DUIs, drunk driving, stuff like that. And then also there's this Water Safety Act, which I had to look up because I wasn't sure what that was. And it's actually the Texas Parks and Wildlife. It's basically their safe boating rules if they are violated. And we can see here that vehicle laws were much higher than the rest of them. Next we see their search, like why it occurred, mostly because it was incidental to the arrest. We also see probable cause and contraband here in this histogram. Next we have if the search came up with anything, and as we can tell, most of the searches actually didn't discover anything. Some of them had drugs, cash, weapons, or alcohol though. The next variable is race known, which is actually the variable that I am going to be modeling later. I wanted to see if the race known affects the officers, if they actually pull them over and arrest them and stuff like that. But you can see that for most of the arrests, the race was not known beforehand. I'm going to skip the X and Y coordinates. I feel like they're not really that important, especially because we have the sector, and I feel like that's a much more important variable. So here we have the sectors, which I will show you. Austin divides their sectors into 10 different sectors. We can see here on this map. I actually live where the star is, which is in Edward, and I work where the box is, which is in Adam. But you can see that Austin is basically just divided up into these 10 sectors. So going back, we can see that Edward actually has significantly more arrests than a lot of the other sectors, and we can also see that in our histogram here. There are some interesting sectors that are listed here, such as HEOOC and APD TAC 1. Not really sure what those sectors are. They weren't listed on the APD website, so I'm assuming they were just misspellings or some kind of tactical group or something. Next we have local field 1, which I think are just the sectors numbered 1 through 10, and so we see them here. So that being said, we're actually going to do some data modeling now. First, we're going to drop the columns that we're not using, so primary key, x coordinate, y coordinate, rep date and location. I'm doing rep date and location, I'm dropping them because they would just create way too many categorical variables and way too many one-hot encoded variables. So we're just going to drop them. So now we have this nice clean data set. So the next thing I want to do is remove the row where age equals 0 because that's just a weird set and I just don't want it in my data. I think it's just an outlier, so we'll just drop it. And then as you can tell, it's actually gone now, so that's great. The next thing is I wanted to fill in the missing data, and what I'll do is use forward fill, so it will go through and take the last known variable and just pull that forward to this missing value. And now we can see that we don't have any more nulls, which is great. Okay, after that's done, we can actually do the one-hot encoding, so we can make our categorical variables numeric, which is done here. Oh, this is actually getting out describing the categorical variables. And here we can see that there's lots of them. So yeah, first I wanted to actually clean up the data a little bit. So I changed for person search description for yes equals 1 and no equals 2. I basically just had them set yes or no. Same with race known. Instead of it being race or ethnicity was known before stop, no race, I'm just going to set it to yes or no. So now that that's done, now it's nice and clean and we have our final data set. Now we can actually go in and one-hot encode the variables and create the dummy variables. And also I'm going to change race known from being yes or no to 1 to 0 here. I could have done that earlier when I was doing it the first time, but it doesn't matter. So now we have our final data set here, and we can see that we have our one-hot encoded variables with sex female, sex male, APD race description American Indian Alaskan Native, APD race Asian, etc. And we can go ahead and see that they're all here now. So now I'm going to pop the race known and set that to Y because that's the variable that I want to model on. And then we'll go ahead and do our test train split just like we've been doing all semester. I'm going to go ahead and do random forest first because it's my favorite modeling algorithm. So we'll go ahead and do the modeling the hyperparameters here just like we did before. We'll get out the best fit here using the grid search CV. We'll get out the best estimator. We'll actually do the estimator and we will get out our AUC score. This isn't the highest AUC score, but it's middle of the road. I mean, between 0.5 and 1, 0.76 is pretty good. Not as good as what my midterm was, but it's all right. As far as accuracy goes, we have a really good accuracy here, which is great to see. Precision recall, we have pretty high, 0.88 and 0.9, so I mean, that's pretty good. That's pretty awesome, actually. And then we just have our cross-validation scores here. Just to compare, I just did a quick logistic regression, scaled the information, test train split again, and then went ahead and did the logistic regression with the L2 penalty, and we did a fit, and here we actually have an AUC of 0.59, so we can definitely see that random forest was significantly better than logistic model 2. Thank you, and I had a wonderful semester.